Before hitting the play button, did you remember to share this on your wall? Oh, great if you did. If you didn't, it's not too late, you can still do it. Please always remember, these videos are educational. They are designed to help as many people as possible, and that can only be possible when many people see it. If possible, all the prospective applicants for Jamb offering maths should see this video. If you know or you think that they have not all seen it yet, then please hit the like button and share the video on your wall, because that could just make the difference between someone passing Jamb maths and failing it. And moreover, it doesn't cost you anything, so please share it. Thank you for sharing. Here comes your video anyway.
Our next question is question number 25. And the question says, in the diagram above, PQ is parallel to RS. Normally, you know, lines are parallel when they are marked by this arrow sign. So without them even telling you that they are parallel, because they are marked by this arrow sign, you already know that they are parallel. The question goes further. The size of the angle marked X is, so they're asking us to find the size of this angle. And when dealing with parallel lines, parallel lines has got a lot of unique angles associated with them. And to get a better understanding of what these unique angles are, I'm going to take you to a site that dealt extensively about the relationships involving parallel lines. And this site I'm talking about is www.mathsisfun.com/geometry/parallel-lines.html. And this site is actually very explanatory. Did a very good job in trying to explain what parallel lines are. Lines are parallel if they are always the same distance apart, called equidistant, that they are the same distance apart, and will never meet. So the good thing to remember is that they are always the same distance apart. The distance here and here is the same between here and here, and they will never meet irrespective of how far apart they travel. And this is true whether the lines are vertical, horizontal like this, or diagonal. And like I said, parallel lines have got unique angles and relationships. And some of these relationships are: one, when you have two parallel lines and a line crosses it like this, the line that crosses it is known as a transversal. I'll go into that later. It creates unique relationships. For instance, the angle here is always the same with that here. The angle here is always the same with that here, and so many other unique relationships. So let me take you a step further and give you a rundown of what all the relationships are. If you want to get a full understanding of what these relationships are, probably because I'm going to go too fast, you can always come back to this site and read it in full. I'm sure the site owner will be happy that a lot of people are coming to his site and hence basically driving traffic to his site. So now the first topic we'll talk about is a transversal, which is this line. A transversal is a straight line that crosses two parallel lines. When that happens, unique angles are created. And I'll talk about those unique angles in detail in a moment. The parallel lines are the two straight lines that will never meet irrespective of how far they travel. So that is this. We have vertical angles. In vertical angles, A is equal to D, B is equal to C, E is equal to H, and F is equal to G. Now we have corresponding angles, which tells us A is equal to E, B is equal to F, C is equal to G, and D is equal to H. Then we have alternate interior angles, which tells us C is equal to F, D is equal to E. Then we have alternate exterior angles, which tells us A is equal to H, B is equal to G. And then finally we have consecutive interior angles, which is C plus E is equal to 180 degrees, D plus F is equal to 180 degrees. So essentially, those are all the topics covered under parallel lines. Of course, in an exam scenario, you are supposed to be able to identify and recall all these relationships off heart. So I will advise you, if you don't already know them, to come to this side and memorize these relationships. So going back to our question now that we know what we know about the existing relationships involving parallel lines, let's go to our green board and solve our question. First of all, we'll start off by drawing our diagram. We have two parallel lines. That's one. I have another parallel lines. I know my lines are not straight, but it will do to solve our equation. So we have PQ and we have RS, and then we have a line cutting across them like this, and another line cutting across them like this. And this angle, according to the question, is 30 degrees, and then this angle is 50 degrees. Now, in a diagram like this, we observe the diagram thoroughly to see whether we can see any relationships similar to any of the ones we have identified earlier on. And looking at this diagram, you will observe that already there is a unique relationship that exists with 50. This angle will be equal to 50. Do you know why? Because they are vertical angles. So because they are vertical angles, that's what makes this angle 50. And if this place is 50, you will observe again that here, here, and here is a triangle. And we know that the total sum of angles in a triangle is 180 degrees. And already we know two sides. So the third angle will not be that hard to find. It's a matter of just subtracting the sum of these two angles from 180. So that will be minus 50 degrees plus 30 degrees. So that will be equal to 180 degrees minus 80 degrees. So that will be 100 degrees. So that means this angle is 100 degrees. Remember, we are told to find this angle here, which is x. If we know what this angle is, I will know that the sum of angles on a straight line is 180 degrees. Hence, x will be the sum of angles on a straight line minus 100 degrees. So, the sum of angles on a straight line is equal to 180 degrees. So x will be equal to 180 degrees minus 100 degrees, which is equal to 80 degrees. And if you look amongst the options we were given, our answer would be B.
Oh, welcome back. Did you enjoy this video as much as I did? Well, I hope so. And did you actually remember to share the video before you started? Well, in case if you did it, it's not too late, you can still do it. If you're watching this video on Facebook, please hit your share button so that other people can see it and enjoy it. And also, hit the like button. It costs you nothing. And if you're watching it on YouTube, please hit my subscribe button so that when I upload new videos, you'll be regularly updated. Thank you.